All right. So thanks for joining this webinar. This is a very unique session. I don't have any slides. I don't have any of the typical content that I package and present. This is a very interactive live session. This session is also streamed on my YouTube channel, Facebook, and LinkedIn. I hope you are able to watch this and listen to the audio. If you have any problem with the audio or the video quality, just let me know with the chat window. I should be able to fix that. All right. So before we get started, I want to set the context and give you some background. For a long time, I think for almost 2 years, I've been advocating the idea of simplifying Kubernetes through a platform as a service like experience. So to really understand the reason why I've been pushing for that and advocating for that, let me give you what it takes to deploy a simple application. So if you come from a PaaS background, for example, a decade ago, I was very fascinated by Google App Engine, Azure Platform as a Service, Heroku, EngineYard, Cloud Foundry, and so on. And even OpenShift before it really became a Kubernetes-based platform. So what was common among these platform as a service offerings? Well, the beauty of that was you push the code and you get back a URL. So that was pretty straightforward. You bring in the code, either point it to your Git repo or your local directory, and you simply push that to the PaaS and you walk away with a URL. And scaling that has been extremely simple. Connecting services like stateful services with stateless services has been pretty straightforward. But most of these platform as a service offerings were black boxes. Like you didn't really know what went into App Engine, what went into Heroku. But Cloud Foundry was different because it was an open source PaaS. And that actually opened up the layers behind the scenes of a PaaS. For example, the Warden mechanism and how the services were load balanced, all of that became slightly more transparent with the evolution of open source platform as a service. But most of the commercial PaaS offerings have been black boxes all along. Then came in Docker and followed by Kubernetes that kind of gate crashed into the party and changed the game completely, making the PaaS very, very arcane and outdated. And everyone moved over to containers, and to manage multiple containers, they needed an orchestrator like Kubernetes. And in no time, Kubernetes has seen extremely rapid adoption. And today it is as popular as Linux. So if you're in the field of DevOps or systems management or infrastructure, it is pretty clear that Kubernetes is the de facto standard for deploying applications. So the era of Kubernetes also brought in some challenges and complexities. Now, what was taken for granted and what was assumed to be extremely simple suddenly became very complex for non-infrastructure oriented developers. For example, if you want to deploy a simple PHP and a MySQL app on Kubernetes, in PaaS, it's been very simple. You first create a service called MySQL, then you code your PHP frontend and you bind your PHP web app with the MySQL service, and boom, you go live. And then you can quickly scale your stateless service without touching the stateful service. But when it comes to Kubernetes, you got to first create a storage class. By default, Kubernetes doesn't come with persistence. So you have to install a volume plugin, then create a storage class, and then create a persistent volume, then create a persistent volume claim. And from there, you deploy a single pod or a stateful set like MySQL or Postgres. And then you create a secret to expose the username and password. And then you create a config map to properly configure the settings of your database. And that's just one part of the story, which is the stateful service. Then comes in the stateless service. There you again create a deployment, you expose that as a service, you got to create an ingress, and you got to mount the secret as a volume, start consuming it. And even before you realize, you have dealt with a couple of dozens of Kubernetes objects, everything from a simple pod to an ingress and everything in between. Now, this is very scary for a lot of non-DevOps and pure play developer personas. And we have been seeing this for quite a while. So this prompted companies like Red Hat to create OpenShift with complete developer experience and platform experience. But given its scale and their focus, it has grown pretty complex. And same was the case with Pivotal, which is now VMware's Tanzu. Now, these are commercially available and, of course, have an open source flavor as well. They are PaaS built on top of Kubernetes. But again, it is not for faint-hearted. If you have ever installed Red Hat OpenShift, you know what I mean. You need at least 5 machines to get your basic cluster up and running. And Tanzu application platform, which was emphasized at VMware Explore last week, is also very, very complex. You cannot simply run it on Minikube, or you cannot simply deal with it in your existing cluster. It's a lot of heavy lifting that you need to do even before you write your hello world. So that has been a big challenge for developers and operators. And there has been a very clearly identified opportunity to simplify developer experience on Kubernetes. But interestingly, there hasn't been a standard. Now, Red Hat OpenShift and VMware Tanzu are more of an on-prem enterprise data center targeted environments. When it comes to public cloud, there have been efforts to simplify Kubernetes experience. Some examples are ACI, Azure Container Instances, Azure Container Apps, AWS App Runner, Google App Engine Flux, Google Cloud Run, and so on. But the problem with this is every service is very proprietary, very, very unique. And there is a steep learning curve involved in each of these services. They don't use the same spec. The way you define your service or your application deployment unit is extremely different from one hyperscaler to the other hyperscaler. And there hasn't been any CNC of project that actually define the application DSL or the domain specific language, or the way you basically articulate your microservices applications and deploy them consistently across any platform that you use, any Kubernetes environment that you use. And that's when Acorn caught my attention. Acorn is very, very new. It's just a couple of months that it's been announced, but it comes from a very credible team that actually developed cloud.com. And if you have been in that era over a decade back, you know what I'm talking about. Cloud.com was actually a very mature private cloud offering that was adopted by a lot of data centers and colo providers to deliver infrastructure as service. It was much better than OpenStack, even before OpenStack got announced. It was around, and it has been widely accepted by a lot of colo providers. Then the team that developed and engineered cloud.com sold that to Citrix and moved on to Rancher. And we know the success story of Rancher. And after Rancher has been acquired by SUSE a year ago or a couple of years ago, the team is back with their brand new startup, and that is Acorn Labs. So Acorn is essentially an open source framework created by one of the most celebrated engineers in the cloud native ecosystem, Darren Shepherd. I'm a huge fan of his work. He created K3S that I use day in and day out. He is the brain behind some of the technologies like RKE2 and Longhorn and Harvester and so on. So the same team is now developing and open sourcing Acorn. And it means a lot to the ecosystem, not just because it's yet another open source project, but it comes from a very credible, very proven set of engineers who actually have a very proven track record. And keeping that aside, personally, I have been very excited about Acorn just because of its simplicity. Now, in many articles that I have written and many panels that I've been a part of, I always ended my discussions with one-liner. The community needs a portable PaaS that runs anywhere from Minikube to a hyperscaler managed Kubernetes and in between. Now, that includes Edge, that includes K3s, that includes pretty much any distribution like Anthos or EKS anywhere running in the data center, hybrid cloud, and public cloud. And Acorn is precisely that framework which can enable you to develop and deploy, not develop, but more of deploying applications from Minikube to a managed Kubernetes cluster and everything in between. So that is very promising, very exciting. And today I'm going to walk you through some of my experiences of using that and some highlights that I absolutely loved about Acorn. So let me go ahead and share my screen. I have spoken quite a bit. Now it's time for me to show you some action. So I'm going to share my screen and quickly move to my terminal. I want to make sure my live stream is on. Okay, so I'll move to the terminal. And I have 3 demos. Now, each demo emphasizes on one aspect of Acorn. So the first one that I want to talk to you about is the install experience and what Acorn does to your Kubernetes cluster. To start with, let me show you my environment. So I have a very simple Minikube cluster up and running. This is basically a VMware-backed VM. I'm not using VirtualBox, so it doesn't really matter. But this is actually a simple Minikube environment that any of us can run with a single command. Now, if you look at the namespaces, I have the Minikube Ingress add-on enabled. Now, that's a prerequisite. So I have gone ahead and ran this command, which is Minikube add-ons enable Ingress. So that actually deployed the Nginx Ingress. That's the only thing that I have done. So in my first demo, I want to show you the experience of installing Acorn. So Acorn is a thin layer, a wafer thin layer that sits on top of Kubernetes, treating Kubernetes as an ideal runtime. So you basically start with Minikube and then you install the Acorn CLI. If you're on Linux or Mac, the best way is to use Brew. I have already gone ahead and installed the Acorn CLI. So once it is installed, we can basically verify its version. I'm running the most recent build. And you got to make sure you're pointing to the right Kubernetes context. So if you look at CTX, I'm targeting Minikube, and that's where I want to install Acorn. So all I'm going to do is run this single command called Acorn init. But before that, let's put our kubectl namespaces under watch and then run Acorn init. The moment I install Acorn, my cluster gets a couple of new namespaces. So obviously the first one is Acorn, the next one is Acorn system. So this is the most simplified install experience of any PaaS. It can't get simpler than this. So now, what does it really mean? Well, we got 2 new namespaces, Acorn and Acorn system, but what really goes into it? So to save time, I have some commands, and all of them are documented in my tutorials, and some of them are going to be published at the news stack in the coming weeks. So all these commands as well as the gists will be published and shared with you. So the first thing is, apart from the namespaces, there is an API server for Acorn. Now, this API service is a Kubernetes API aggregation service. What it basically means is it sits alongside the Kubernetes API and just tunnels the requests that come to the API server to its own controller. There are a lot of advantages of doing this, and there is a best practice behind this. Instead of exposing this as a service and putting that as a node port or a load balancer, by using Kubernetes API aggregation, there are a lot of advantages. And the first one of that is an RBAC definition. So this api.acorn.io can be used for restricting developers to deploy the application by creating role that explicitly gives permission to this. Now, all other namespaces can be law, and only the Acorn API can be opened up through the service account or a set of users associated with the certificates, and they can only deal with Acorn. So very well designed API server aggregated into the Kube API server, which will enable RBAC. So that's the first entity that Acorn installs. The second entity is obviously a CRD. And this CRD, there is only one CRD, which is app instances.internal.acorn.io. Now, obviously, you need a CRD if you want to build a PaaS on top of Kubernetes. But what I like about Acorn is there is one and only one CRD, a custom resource definition that's called app instances. Now, this is the representation of an Acorn application. So when you define an Acorn a microservice definition or a declaration, and when you throw it at the Acorn API server, it basically uses this CRD to internally represent the Kubernetes objects. So it is, again, a collection of various Kubernetes objects that represent an Acorn deployment. And the way to identify that is through the CRD, which is app instances.internal.acorn.io. So after that, let's take a look at the Acorn namespace. Now, Acorn namespace in itself is empty. It doesn't have anything, but it is reserved for the CRD instances, the custom resources that we create as we go along. So currently it is empty, it is just a placeholder, but as we go along and deploy applications, this namespace is used to essentially deploy the app instances that represent an Acorn app. So that's the reason why it is empty. But the heavy lifting is done inside the Acorn system namespace. And here you can actually see that, there are a couple of pods, there is a service, there is a replica set deployment and so on, right? So obviously, if you look at get deploy, you will see only two deployments. One is obviously the API logic that is wired into Kube API server, and Acorn controller, which is actually responsible for decomposing an Acorn file into the nuts and bolts of Kubernetes objects. So that is where the actual heavy lifting takes place. This is the heart of Acorn, where everything gets translated. Now, this becomes very clear when we deploy our first application. Now, there are a couple of services, obviously. There is Acorn API, but this is not exposed to the outside world. It is just for the controller to interface with. So that's all we have. Now, what I absolutely love about Acorn is the power of one. There is one API, one CLI, and of course, everything has one CLI, but one CRD, one controller, and just one mechanism to define the RBAC. Now, that's the reason why I call this as a wafer-thin PaaS layer sitting on top of an ideal runtime like Kubernetes. Very powerful, yet very simple. Now, let's go ahead and write our first Acorn application, the most simple application that we are going to deploy. Now, what we'll do is we will take a look at the Acorn file. So Acorn file, I will actually highlight this with syntax of JavaScript. I think that makes it slightly better and readable. There we go. So this is the hello world example of Acorn. It can't get simpler than this. So this is basically like a pod. It's in fact a pod, or rather a deployment. And it comes with the image that you want to deploy, the port that you want to expose, and publish is a special hint to the controller that this is not just a port that is being exposed, but this is actually wired to the ingress. So publishing a service is wiring it to the ingress. If you want to just expose something internally like a Redis or a Postgres, then you don't need to use publish. You'll actually use expose. So publish is to basically wire up with the ingress. And then we create a simple file, which is using the key value structure. The file name itself is the key and the contents are the value. So this is the high level domain specific language that is based on another language called CUE. And it is also highly inspired by Docker Compose, which I'm going to touch upon, and highly inspired by JSON.NET, which I don't like personally, but it has its own advantages. So this is not just a static way of defining. You can include some business logic. You can include some automation logic. You can write regex expressions. You can do a lot more than what you can do with YAML. So this is actually better than using Helm, because Helm has grown in its complexity. You know, the scaffolding and the templating and all of that has become very, very complex. Customize is slightly better, but they are meant for different purposes. But I find this DSL is very intuitive for developers to kind of visualize, articulate, and define the way their application is structured. So let's go ahead and deploy this. All I'm going to do is run this, run the application, because Acorn file is in the directory. It's almost like how you do a Docker Compose up. So Acorn run will now takes the Acorn file and then launches something called the build kit, which is responsible for building the image and throwing that into its own registry. So now when we actually go back to Acorn system and look at the namespace, you actually see that 30 seconds ago, there was a new pod that got created. Why is this required? Well, this is required because Acorn has packaged our application into an OCI manifest and pushed that into its own registry. So the packaging is done within the build kit. The storage is done within the OCI registry. So if you decompose build kit D, it has two components. One is the build kit, which is responsible for packaging the OCI artifact, and the other one is registry, which is responsible for storing it. Okay, now I can go ahead and check all my applications. So Acorn apps will show me that this is the URL of my application. Now I can simply grab this. Oops. I can basically copy the host and use curl with a header. So let's use this as the host. And I have my DNS entry set up for Minikube, so I'm going to use that. There we go. My first Acorn. Now that is exactly what I have defined in my Acorn file. So pretty straightforward. But behind the scenes, there are some interesting elements. Now, if you actually notice, there is a namespace called white shadow followed by a hex code. Now, I'm seeing some questions, but I'm going to park them towards the end for the last part of this session, the Q&A. So keep those questions coming, but I'm going to address them towards the end of this. I don't want to break the flow of this session. Thank you. So now when we look at what went into this namespace, you notice that there is a deployment, which is a combination of pod and replica set. And there is a service, but this service is a cluster IP. It is not a load balancer. It is not node port. So obviously that means there is also an ingress that's been created. So if you actually get the ingress from this namespace, that is the host wired into the ingress, and this is the name, and it is pointing to the Minikube IP address. So everything that you need to do as a DevOps engineer to deploy an app is done by Acorn. It has taken your image, turned that into a pod or a deployment, exposed that as a service, wired that up to an ingress, and has thrown a URL. Now, this is the promise of PaaS. Come with your code or a container image, go back with the URL. And that is the power of PaaS, which is finally available on any flavor of Kubernetes, starting from Minikube to a multi-node cluster running in a hyperscaler. So this is the simplistic deployment of an Acorn application. So I want to stop here, pause here, and summarize what we have seen so far. So we have installed Acorn, and Acorn has done very slight changes to the cluster. It installed a CRD, an API server, a controller, and it basically created the core platform experience for us to bring a file called Acorn file. And when you throw that to Acorn, it goes through the API, hits the controller, and controller decomposes your Acorn file into set of Kubernetes objects, all the way from wrapping it into a deployment and exposing that through an ingress. So all of that was the core focus of my first demo. Now, the second demo gets slightly more interesting and more real world. So, and this is where we also get to see different dimensions of Acorn. So let me close these files. Now, I want to show you something that all of us are very familiar with. Now, this is called the Azure voting app. Now, this has been one of my favorite hello world examples on Kubernetes. You know, it actually deploys a Redis backend, I think a Python frontend, and does some pretty cool voting application for us to test. So how about taking this and deploying that into Acorn? So this is available on Azure Samples GitHub. It's very easily available. So this is not a custom app. I have borrowed the Azure sample because it is one of the simplest ways of breaking down, you know, everything that it takes to deploy a multi-container, multi-tier application. So now let me show you the Docker Compose version of the application. So this is the Docker Compose version of the Azure Vote application. So let's actually see this in action. So I'm going to simply bring the Docker Compose application. So Docker Compose up. Now this is running on Docker desktop. Now in no time, this shows up and I can actually open this in browser. So I am exposing this on port 8080. So let me show you how this looks. So there we go. So this is the Azure voting app. You know, you can vote for cats, dogs. Pretty cool way of understanding how microservices work, because there are two containers working in tandem. Now, our goal is to take this and turn that into an Acorn app. So we have three flavors of the same application. One flavor is the Kubernetes version, okay? And the other one is the Docker Compose version. Now, obviously, the Docker Compose is much more compact, but there are some challenges with it. That's the reason why Docker Swarm didn't take off. Still Docker Compose is popular for a lot of developers trying to understand multi-container workloads and microservices. But when you bring that over to Kubernetes, this becomes very verbose. So if you see, there is a deployment, there is a service, there is another deployment for web app, and there is another service that is exposed as load balancer. So now, how do we take this and turn that into an Acorn file? Well, let me do this. So I'm going to open one more window, and that is going to be the Acorn file. Okay, where is my Kubernetes YAML? Okay. Okay, so again, I'm going to set the syntax just to make this a bit readable. Okay, so this is the Acorn file for Azure Word application. Now, if you look at the Azure Word back, this is coming from the Redis container image, pretty straightforward. And then we are again exposing this. Now, expose basically translates to a cluster IP, which is limited to that namespace, limited to that application. The developer doesn't need to know about the difference between cluster IP, node port, load balancer, and ingress. But the idea here is I want to have a name assigned to my service so that I can easily scale and I can expose that internally to my application. And by default, Acorn, everything is private. Unless you expose or publish, everything is closed. So you cannot even interact with it, even though they belong to the same application. So we first get the Redis image, and then we expose 6379 to the application. And we set an environment variable that says hello empty password to yes. And then we define the Azure Word frontend, which is coming from this image. And then we publish this because we want this to become available on the ingress. And we are using the environment variable to basically wire the front end with the back end. That is the Redis environment variable. And here is depends on. So depends on is a lot like an init container. Behind the scenes, it is like an init container with a kind of a check, that makes sure that this pod or this deployment is up and running. So this is the sequence. And interestingly, we have something very similar even in Docker Compose. So, in Docker Compose, you have depends on. So that is now carried over to Acorn file. So now we are actually looking at a multi-container application. To keep this simple, I'm not turning this into stateful. I can very quickly create a volume and mount it inside my Redis container so I can persist this state. If you want to take a closer look at that, if you want to see an example, you should watch Darren's session where he took the guestbook sample and turned that into stateful. But we are talking about two stateless containers here. So let's go ahead and deploy this. Now, I want to show you how to remove an app. So when we look at Acorn apps, there is this random name given to our initial application called White Shadows. So let me get rid of that. Acorn RM, and this is going to terminate the namespace and remove all the associated objects. So now we have an Acorn file and we can go ahead and run this. So that's it. Now, this is going to take both the container images, package them up, push them into the internal registry, and very quickly throw a URL that we can access. So at this point, it is just collecting all the assets, all the artifacts needed for that deployment. And now it is called Proud Moon. So let's go ahead and look at the apps. So okay, now it's assigned. So the Azure Vote friend is available. So let me grab the host name and go back to my. So I love this extension to Chrome called the mod header. So you can actually put a host and change this. So now if I hit Minikube, which is my DNS entry for the Minikube IP address, we're actually seeing an Acorn app. You can vote, you can do a lot of stuff. So this is pretty cool. So now we are accessing the Azure voting app, which is an Acorn flavored application. So we simply packaged it up as an Acorn file, and we have exactly 2 container images. And if you go back to the namespaces, you will see everything that you are familiar with. So if you look at everything inside this, obviously, there are 2 deployments, 2 services, and 2 replica sets. There is also an ingress, which is actually pointing to this host. So this is how you package multi-container applications. So this is, again, the next level where we have gone slightly beyond Hello World. But the dev to production workflow becomes very interesting with Acorn. So that was the second demo where I have shown you, the fundamental differences between a Kubernetes YAML file, a Docker Compose file, and an Acorn file. So let me show you the workflow involved in, iterating over the applications and then taking them to production environment. Unfortunately, I couldn't get this running on AKS cluster in the last minute. I had some issue with the ingress, but nonetheless, I'll show you everything except the AKS deployment, which is actually my production environment, but I can turn my Minikube as well into a production environment, and I'll show you some tricks towards that. So let me show you my third demo, where we don't deal just with pre-built images, but we iteratively develop and push them to our cluster. So developers want to debug applications faster. They want to iterate over the code faster. Now, one of the biggest challenges with Kubernetes, unless you're using some tools, the painful process is, okay, I write the code, then I turn that into a Docker image, I push that to the registry, then I deploy it as a pod, and then I actually see how it works inside Kubernetes. And if you want to modify something, even a small part of code, you got to go through this process all over again. And every time you push the image, you got to refresh. So the development cycle is not very intuitive. And that's where the difference between PaaS and Kubernetes becomes glaringly visible. But there have been a lot of tools and approaches to fix that. For example, Ambassadors, telepresence, and some of the tools that they have, and code spaces, they try to fix that problem, but Acorn makes it much more easier. And as soon as you touch the Acorn file, it automatically rebuilds and deploys, and you can just refresh the page to see everything in real time. So let me show you what I have in store. So I'm not going to use AKS, but what I want to show you here is the Acorn file, where I'm actually not using an image, but I'm using the build. So this is exactly like Docker Compose. In Docker Compose, you can use build and a dot representing a Docker file in the current directory, and then Docker Compose would go ahead, build the image, push that to the registry, and then deploy it. So Acorn pretty much imitates that workflow. But the beauty is when you're running Acorn in iterative mode, as soon as you touch this file, it rebuilds and you can update the application. So what we are going to do now is, again, let's get rid of the previous application called Proud Moon. So I'm going to remove this application. Okay, it gets terminated. And then I'm going to give a name to my application. Let's call it vote. And then I'm going to introduce a switch called I, which is basically iterative. I have read in GitHub issues and Slack channel that this may be replaced by -d, which is meant for development, but -d has a different connotation. For example, it could mean you're running it in the background. Typically, if you're coming from a Docker context and Docker background, -d always is like, okay, you push it to the background, run it as a daemon. So I think .i is much more intuitive and represents iterative development. So now I have done two things differently in this. One, I'm not bringing all the images. If you actually see the source code, I have the source code available in Azure Vote directory. You have the main.py, some static assets, some templates. It's a simple Django application. So I have that. And then there is a Docker file, which is basically building that application. So it is installing Redis in the container, and then it is adding the Azure Vote directory to the Docker file, Docker image, and then building up the whole image. So we have the Docker file in place. Now, that is the first change. So we are not bringing pre-packaged Docker container images. We are building as we go along, number one. Number two, I have explicitly given a name to my application, and I am actually starting this with an interactive mode. So let's go ahead and deploy this. Oops. Okay, let's call this. Okay, now, as you see, this is actually building the image for the Django application. Redis comes straight from the Microsoft Container Registry, but the Django app is being built based on the Docker file, and then it gets pushed into the internal registry, and later on, we can actually access that. So let's wait for this to get completed. And then we're not going to see anything new, anything fancy. We'll pretty much see the same Azure Vote app. But what I want to show you is, as a developer, how can I quickly iterate over my code and configuration and just refresh the page without doing any plumbing or any Kubernetes related workflow. So now this is deployed. So we can check Acorn apps, and yeah, here is the application. So we can grab the name, go back to Chrome, change the header. Okay, so nothing fancy. This runs as is. Now, just to make sure we are still okay. Now I want to delete this and create a new header just to make sure we are using the most recent one and not the old one. So that's the header that we are setting. Okay, I had an intuition that this is not working. So let's see where we are going wrong. So this is a live demo, and we are working on a product that's just 2 months old. So bear with me as we debug this in real time. So the logs seem to be okay. I want to make sure the header is correct, and okay. Oh, this is the host. Okay, let's check. Oops. Okay, I'm going to just try this again. So I'm going to remove my app called Vote and run this all over again. Let's give this a different name. Okay, I'm seeing some questions coming in. I'll definitely try to address them. Okay, now we have a new endpoint. Let's see if we can do a curl at least. Okay, that seems to be working. So I think I have a problem with the header. So let me bring this up. Okay, there we go. So now this is working. We are able to, again, do this. But let's say we want to keep this application running, but I want to turn this application from voting for cats and dogs to voting for Marvel comics versus DC comics. So I want to turn this into a comic voting app. So all that without building a container image, packaging that as a pod and all of that. So I'm going to completely bypass that workflow and build my application almost all over again without touching anything here. So what I'm going to do is the Azure voting application has a pretty cool configuration file from where it reads. So I'm going to change a few strings here. So this is a comic voting app, DC and Marvel. So we have fans for both. So let's see how this comes along. So now I have changed this. Now all I'm going to do is literally touch my Acorn file and see this getting rebuilt. Okay. Now it is basically picking up my static configuration and some source code changes that I may have done. And now it is in running state. I come back here and do a refresh, and there we go. This is fantastic. Now, we have basically modified the code and accessing that in real time without ever building an image and going through that drill of deploying to Kubernetes and waiting for it to pick up. No canaries, no blue greens and all of that. We haven't hit that point yet. But during the development phase, this is the delight of a developer. This is very, very cool for a developer where he's able to modify his source code, touch the Acorn file and see the output in action. So, this is the beauty of Acorn, where it brings the best of multiple worlds. First of all, it brings the best of Docker and Docker Compose. It brings in best of Cloud Foundry. And on that note, I want to show you something very cool. So we have this running. Now, I want to bind the Redis instance that is powering the comic quotes application in a different application, right? So I want to share the Redis database between two different Acorn apps. And this is very similar to the Cloud Foundry way of sharing resources. It's also called binding. So what I'm going to do is I'll go back to my demo 2 and I will show you a simple Acorn file. And this has nothing but a Redis image. Very straightforward, very simple, right? So let's run this. So I'm going to call this I'm going to call this as Redis client, and I'm going to call this Redis client, and we're going to link this application with the vote application that we have launched in the previous step. So if you look at the comic vote, that is the name of the Acorn app. So if you do Acorn apps, comic vote is the application name. So I'm going to give that as the name. So comic vote is the name of the Acorn app, and Azure Vote Back is the component's name, which is basically responsible for running Redis. And I want to launch a new application. while reusing the existing Redis container. So let's go ahead and do this. So now we are actually launching a new Acorn app, and I'm calling that as Redis client. So now when we do Acorn apps, we have a Redis client running. It has no URL. It doesn't need one because we want to access the Redis. So now I'm going to use Acorn exec. So when I use Acorn exec, this is another cool thing. So you know what it takes to perform kubectl exec. It's a pain to find the number of containers inside a pod and access the exact container. But when you actually do an Acorn exec, it gives you this CUI where you can choose your target container. So now we are inside the Redis client. And I can now actually use the Redis CLI to connect to the Azure Vote Back instance. And there we go. What are we doing here? We are basically binding the Redis service with a new front end or a new application while sharing the resource. So this is very similar to Cloud Foundry resource binding. If you're coming from a Cloud Foundry background, you know this really well. So now we are accessing the same Redis instance that is a part of the comic vote application. So here I'm going to run the keys, and you actually see the keys that were created in the previous examples. So initially we created dogs and cats, and then we moved on to Marvel and DC. So now I can actually see how many votes dogs got and how many votes cats got from a Redis client, which is talking to the Redis instance that belongs to the comic vote application. Isn't this cool? Now, behind the scenes, there is very optimized engineering that has gone into it. Now, what actually happens is, if you look at the namespace, there is a new namespace for Redis client. Let's grab that. And when you see the service inside that, there is an Azure Vote Back service with an external name, and there is no cluster IP, but it is pointing to the comic vote Acorn application. Now, this is a very clever use of external name that no one cares to use. We have used this extensively when we talk to RDS databases from Kubernetes, because RDS already has a well-known, well-defined FQDN, and you want to consume that in Kubernetes. So how do you register an existing RDS? Well, you create a headless service. You call that as an external name service, and you point it to the RDS FQDN, DNS entry. And it almost looks like a native Kubernetes service, but in return, it actually gets forwarded to the DNS. And here we are simply getting forwarded to the comic vote Acorn application, which is running in a different namespace. And this is a very smart way of connecting existing services with new. This is actually called linking. So if you look at the way I launched my Redis client application, it was pretty straightforward. So I simply gave the name of the application and then pointed it to the container image name. And there we go. We end up creating an external name and we can talk to it. So that was a whirlwind tour of Acorn. I covered 3 things, all the way from install experience. Second, deconstructing an Acorn app and comparing and contrasting that with a Kubernetes YAML and a Docker Compose file. And then in the third demo, we have seen how to do iterative development and resource binding, which are very powerful concepts. Now, again, this is just scratching the surface. In the next session that I'm planning to do, I'll actually show you how I develop on Minikube and deploy it on AKS using a production grade ACR container registry and a production grade cluster, where I don't need to build images. I don't need to store them inside Acorn, but I basically redirect Acorn to a trusted registry for OCI artifacts, and Acorn will only deal with it. So that is the production workflow, which I'm saving for the next session. So that brings us to the end, and that actually brings me to the Q&A session. So I'm going to stop sharing my screen and look at the Q&A tab for interesting questions. So it's time for me to wear my reading glasses. The font that Zoom gives is very tiny. So let me put this up and get to the Q&A. So the first question is from Oliver. If I want to deploy 2 to 3 app instances of the same, each in their own Kubernetes namespace, how do you recommend we manage additional AWS infrastructure and Kubernetes? Well, this is not an Acorn specific question, and it also it deserves a very detailed response. It borderlines to creating multi-tenancy and virtual clusters. So unfortunately, I cannot answer that. The second question is, what about a microservice? What about microservice type apps where each microservice has an image or container for the code and a DB, which then needs to interact with other microservices that have similar composition? Well, that is linking and binding for you. I have just covered that in my previous demo. I think this question came up before I showed you linking. How does Acorn deal with distributed apps, microservices that are not built in the same Acorn file, but are built with different repos and deployed to the same, again, exactly the same concept of linking and resource binding? Use the headless service and external name, forward it to the other namespace, as long as you have an RBAC that is allowed to do that. Acorn initializes in the cluster using local users' credentials in kubeconfig? Absolutely. Acorn just assumes whatever kubeconfig file your kubectl is pointed to. So to install Acorn, you need to have permissions. You need to have enough privileges to install all the components of Acorn, but that is only for the admin to do it one time. But for developers, as I mentioned, you don't need to have administrator or elevated privileges. As long as your RBAC allows you to deal with Acorn API, you can pretty much deploy the applications. But Acorn simply piggybacks on your kubectl, kubeconfig, and Kubernetes context. It doesn't need any other configuration file. Excellent. So that brings us to the end of this session. I addressed all the questions. I hope you like this session. I'm going to bring more deeper dives as I explore, discover, and experiment with Acorn. I'm going to translate them. Everything that I've shown today will be published as articles and tutorials at the New Stack in the coming weeks. So subscribe to the RSS feed of the New Stack and keep an eye on that. So everything is documented. Everything is available for you to try on your Minikube cluster. So thanks again. I hope you found this session useful. I had a lot of fun. I hope you had fun too. So I'll see you in my next session. Thank you.